Hello all. So today we will talk about exercise 8.38, coin on a plane. And this question is basically about a uniform coin on a plane, inclined at angle theta. And there's some sort of static friction mu s. Let's just call it mu for simplicity's sake. And it's asking us what's theta max so that this coin rolls without slipping. So now let's first think, when the question says rolling without slipping, we should think immediately to the no-slip condition. The no-slip condition is A equals to R alpha. And so using this condition, we'll be able to solve for the answer. So basically now what we want to do is that to write out the formula for the acceleration, the translational one, and then the other one for the rotational one. And then we can connect these two via this formula, or rather via this condition. Both need to satisfy this condition in order for this coin to roll without slipping. So let's try to do that. So why don't we analyze accelerations along the plane? So this coin experiences a gravity, a normal force, and a friction. So along the plane, we have mg sine theta, because this is theta. So this is mg sine theta. So mg sine theta minus f equals to ma. This is along the plane. And then we have, for the rotational one, we have r times f equals to I alpha. R is the radius of the coin. And so why do we not consider the acceleration perpendicular to the plane? Because, well, we are just considering the motion down the slope and how it doesn't slip. And so it wouldn't really help us to consider, and also there's no acceleration perpendicular, and that's why we don't need to consider it. And next, let's try to connect these two. So let's try to first solve for f here. Well, we know that alpha here is a over r from this condition. So we know that alpha equals to a over r. So we know that rf equals to I times a over r. And so now we know that r times f equals to half mr squared a over r. This is the rotational inertia for a disk. And since a coin is sort of like a disk, so it's sort of like a disk, we can use this moment of inertia. And so we can cancel out the r, and we will get f would need to be equal to half m times the acceleration linear, the translational acceleration, in order for this coin to roll without slipping. And so now if we have this condition, we can put this back in this formula. mg sine theta minus f equals to ma. So why don't we plug this into here? So we have mg sine theta minus half ma plus equals to ma. And so cancel out the m, we have g sine theta equals to 3 over 2a. And so now we know that a is 2 over 3 g sine theta. And then now we can find the f by plugging it back in here. So we know that mg sine theta minus f, it needs to be equal to 2 over 3 mg sine theta. And we know for f, friction, it is smaller or equal to, for static friction, it is smaller or equal to mu times n. N is the normal force. So why don't we rearrange it? So we know that f is equal to mg sine theta minus 2 over 3 mg sine theta equals to 1 over 3 mg sine theta. And we know that f is always smaller or equal to mu n. So what does that mean? Well, that means this force right here, it needs to be smaller or equals to mu n. Otherwise, the coin will start slipping because the friction can only be so big to support such a large translational acceleration. If the translational acceleration is larger, friction wouldn't be large enough. So it might even need to be larger than mu n in order to support the no slip condition of r alpha equals to a. And that's why we can list out the formula 1 over 3 mg sine theta must be smaller or equals to mu n. And what do you know what mu n is? What normal force is? Well, normal force, if this is g, this is theta, normal force is just mg cosine theta, right? So it is smaller or equals to mg cosine theta. Canceling out the m and the g, we have, let's move the cosine to the side. So we have 1 over 3 tangent theta must be smaller or equal to mu. And so we know that tangent theta must be smaller or equals to 3 mu. And theta must be smaller or equals to arctan 3 mu. And so we know that theta max, the maximum value of theta, is equal to arc tangent of 3 mu. And that is our answer to this exercise. Thank you for watching.